Hi, my name is Hsiu-Pang, and in this part, we'll talk about the corrosion problems on solar wrecking in Taiwan and how to reach corrosion resistance in a environmental friendly way. So if we look at Taiwan's 2025 renewable energy plan, we will see there are 20 gigawatts of solar energy plants are going to be built. While if we consider Taiwan is an island country and has a great population on it, we see most of the solar energy plants located nearby the sea. And the plant may just be set in the swamp, salt pans, or the coastline area. These are somewhere harsh corrosion conditions to metal materials. According to the long-term collection of Taiwan's corrosive environments by Ministry of Transportation and Communication, the domestic corrosive level of iron is C5 to CX based on ISO 9223 classification. And of zinc is C3 to CX, is extremely high. One of the reasons is the rainfall. The average annual rainfall of Taiwan is 2.4 thousand, double the world average. This is one of the key reasons for failure of using the magnesium aluminum alloy coated steel in Taiwan. And except for the rainfall, other factors of corrosion there include humidity, harsh weather, salt like chloride and sulfide, and also dust. Those make metals corrode within years. For example, zinc galvanized steel is applied in Penghu, which is a CX outlying land of Taiwan, is generally rusted to the core of iron steel. And aluminum and magnesium aluminum alloy coated steel are no exception to be failed. So we know there are two main types of corrosion. One is chemical corrosion, since many solar plants cases are located on the coastline or industrial park. The chloride, nitride, or sulfide will chemically react with zinc or other galvanizing metal, the protecting layer being consumed rapidly. So the other type is galvanic cell corrosion, which occurs when a salty, humid is on the heterogeneous metal. It's often happening at the cutting edge, bending, or scratches. So now, a solution to this is to apply a coating on the galvanizing layer. The organic coating, the base primer, and the finishing here are durable against chemical corrosion factors. While there are two main handicaps to applying coatings on galvanizing metals. One is the bonding between the organic coating and the surface of the galvanizing patina, which includes like various kinds of zinc compounds, and they are not easy to combine. The other reason is the surface roughness of galvanizing is always low, especially in galvalume and magnesium aluminum alloy coatings. Paint can stay stably on the galvanizing. So a conventional method is to do like sandblasting or acid pickling to roughen the surface before applying the paint. This causes a loss of valuable galvanizing materials. And besides, the roughened zinc surface is easy to be oxidized. White zinc compounds occur rapidly within a week under normal conditions. So here, E3 offers some duplex system solution for production in manufacturing plants and on-site remediation purpose. Inside the factory, we want to produce anti-corrosion rating fast and stably, and so reduce the cost. While for on-site remediation, the solution has to be simple, less pre-treatment on the racking, and better, no need to do any pre-mixing of the paints. Okay, for solar racking production in the factory, we offer a solution for carbon steel and galvanized steel. For carbon steel case, we have heat setting and cold setting method. Both need sandblasting, then base primer, then the finish. The advantage of using our solution is to avoid the galvanizing process because we know it is expensive and take a long time to wait for. And for galvanized steel, since the sacrificing layer is there, which is the zinc or magnesium aluminum alloy, we apply the DTM finish coat onto it, prevent the weight loss of the zinc, as we mentioned before. So if we compare the process with the conventional one, we can see obvious process shortening by using the E3 solution. For the carbon steel case, 2 coats after sandblasting, and for the galvanized steel case, only 1 finish coat after degreasing process. This saves a lot of energy, carbon dioxide emission, time, and cost. Okay, so to evaluate the pan-coated carbon steel, we reference the regulation for wind power and petrochemical tanks. We follow ISO 12944-9 cycling test method, but the thickness is fixed at 100 micrometer to make sure the cost will be controllable in the future. And after 4,200 hours of testing, the trippage of the scribe line is less than 8 millimeter, even less than 6 millimeter. We did an IEC cycling test for 4,200 hours as well, and reveals excellent corrosion resistant property as well. And the galvanized steel case, we evaluated corrosion resisting property in different view specs. In the left chart, the coating contains some special corrosion inhibiting factors to slow down the rate of zinc oxidation, which means prolong the lifetime of the steel. The vertical axis is type of galvanized steel, and we did test on. The blue bar stands for the white zinc period time in bare cases, and the yellow bar stands for applying our coating onto them. So we can see around 5 times increasing in the oxidation time to the GI zinc galvanized steel, and 3 times to the galvalume, and the magnesium aluminum alloy with or without nickel, all presenting excellent corrosion resisting properties, and even better with E3 DTM applied. Zinc white has not occurred when we stopped the test at the 4,200 hour time point. We compared the GI galvanized steel coat with our DTM pants and commercial DTM pants. Our result shows a great coating quality even after 4,200 hours of cycling test, while the commercial ones start to have some blistering phenomenon, which tells the interface changing between the coating and the steel. And at the scar site, here at the scar site, some brown rust can be observed. There will be a huge risk if applied in the real world. There was our baking pans or cold setting cross-link pans for manufacture in a factory. Well, more galvanizing steel cases out there are not having any coating on them, and it's now facing corrosion risk waiting for rescue. To those repairing requirements, we have launched a product portfolio and operating regulation for different cases. The product includes a preservation anti-corrosion paint we call AP23S, which also has high durability to UV sunlight. a metal-based anti-corrosion paint, AL10S, and a rust transferring primer, TNF120. With the right procedure of coating, the lifetime of steel can prolong by like 5 to 15 years of use. AP23F, similar to the previously mentioned DTM baking paint, contains some special inorganic passive factors to prevent the zinc from oxidation. If we compare the AP23F with the two commonly used commercial zinc-rich repairing paint by putting in the STM B117 testing system for around 2,000 hours, we can see excellent corrosion resisting properties of the AP2CS on the GI galvanizing steel. Even at the scar site, we see label 10 quality of corrosion resisting of AP23S. A small molecule anti-corrosive diol agent is used in the system to refill the scar on the steel. Okay, and here is a demonstration to spray coat the AP23S paint on the galvanized steel. Okay, so far I have given you guys an idea of the E3 corrosion resisting product. And one thing we do care about is the long-term toxicity issue of solar rakings. Well, galvanizing now is the main solution to the corrosion resisting purpose, but one characteristic of the zinc compounds is it is aquatic environmentally toxicity. Just 1 ppm in the water could lead to the death of farmed fish. And since fishery PV has great potential in Taiwan and over the world, and as we just mentioned a few slides before, zinc compound easily to be dissolved in water. So it's a problem that we can disregard. So a coating solution to the galvanized steel could be helpful, but also toxic hazard elements could be contained in the patina or coating, for example, like hexavalent chromium, BPA, the bisphenol A, or lead are commonly to be found in a corrosion-resisting coating system. So what also we claimed in our coating technology material is about material safety. It is not easy to go too deep technology-wise, but reaching some criteria for food equipment or food packaging could be a way to clarify the property of non-toxic. So what we are able to claim in the paints are ROSH compliance, which includes lead, chromium, and some other heavy metals, and BPA-free and zinc-free also. Okay, so thank you for your attention. It's my presentation. And if you have some questions or interest, you can contact me by mail, and you can download the slide with the code up here. Thank you very much.